course, it's possible to generalize, and you will generalize. It's just that this generalization is not necessarily the human language kind of generalization that presumably we have been trying to capture with psychological studies.
Okay, so we questions. So let's see. Maybe I'll ask a question. Let's see. I haven't been reading up on the Q&A questions very well. So maybe. Is there anyone live who'd like to ask a question first while I become better informed? Eleni, go for it.
I don't know. I'm gonna go ahead.
Oh,
Ishita. Okay, sure. I'm just adding because I don't think I can see everybody else. I was curious about, so I think it came up in a few different talks that like the capabilities that are spectrum around what people usually study within cognitive science and linguistics. So there's things on this side, like things that Tim mentioned about just consistency across different modalities. Things we haven't studied that much because we kind of just took for granted. We just assumed everybody could do it until we found a system that can do some other things, but suddenly can't do this. And there are things on this other side, like generating a unicorn on TXC, which is definitely not something that we usually study within our field, but something that these models can surprisingly do. So I'm kind of curious about, like, so it feels like a sort of a spectrum, and most of the stimuli that we've developed within cognitive science and linguistics are sort of like this edge, in this edge space where it's sort of like kind of within the realm of what things people can do, but sometimes people mess it up, so it's kind of interesting to study. But it feels like there are things, there are capabilities that are not within that bubble that become relevant when we're trying to evaluate or understand these alien systems. And I just wanted to hear people's thoughts on like what are like, what are the things that my sense is that the skill set that we've developed as cognitive scientists and linguists still transfer very well to these, because we have a sense of experimental design, we have a sense of how to design hypotheses around these different things. So I'm curious about how people feel about it, like how, like, so you're divorced from the content, but you use maybe similar methods, and I'm curious how the panel sort of thinks about problems in these areas.
I mean, I guess I would say like some of those problems that Adina mentioned, like test taking and AP US history and whatever, like maybe they start to move out of cognitive science and into the kinds of things that people who work on education study. So there is like plenty of work in education on, math word problems, but also reasoning and like LSAT problems, I think on like fact-based memorization. And so it's cog-sci adjacent, but in there, although I also appreciate the point that like the way those kinds of evaluations are being implemented is often not under the umbrella of people studying it from those kinds of perspectives. But yeah, maybe that's something that we should be thinking about more.
Yeah, and just to comment on this Big Bench example, yes, these examples did not come from linguistics or cognitive tradition, but honestly, I'm not sure that they came from any tradition. There doesn't seem to be any theory underlying the selection of tasks, and it just whatever people could find and put together. So I'm actually not sure how we feel about that situation. If the evaluation is just not theoretically motivated in any way. But that's the current status.
Yeah, so I think there's one very specific way of thinking that is very prevalent in linguistics and cognitive science, but also relevant to pretty much every evaluation, which is thinking about generalization. So I think there is this core idea in linguistics that if you want to understand what linguistic abilities a person has, you need to look at their ability to handle novel examples. So for example, WUG tests are the classic case of this. If you want to see if a child knows how to form a plural, you give them a novel word to make sure that they haven't just memorized the plural forms of all the words that they've seen. And I think that this general way of thinking is important for any evaluation, because for any test you want to run, the potential of having seen those examples before is a potential confound you have to be considering. But even beyond the sort of exact memorization, I think there's also more nuanced senses of having seen the same example, where it's not only a problem if you've seen this exact same example, but also if you've seen similar types of examples. So I think being able to think about these types of controls that need to be run in order to be confident that the abilities we're seeing are abstract and generalizable, it is an important type of mindset that will be relevant, even if the ability you're investigating is not one that's going to show up in linguistics or cog-sci publications.
Yeah, so I take the question to be about like there are these like new observations that like don't really fit into like the like previously defined or like studied phenomena that are still interesting, right? So I think linguists and cognitive science think a lot about like what are good abstractions. I think I mentioned some of this in the talk, and I think like that is really necessary to build any systematic evaluation on the cases that we observe. So, you know, like we find this like unicorn taxi example, like if we wanted to systematically test that, like what is like the right level of abstraction to test that and what are good instantiations of the benchmark? I think like that's a good question. And I think like kind of whether you want to treat it as like an application oriented task versus like, are we going to decompose it into some more kind of core cognitive capacities and like test for that? I think that's also like a decision that we can make.
Okay, let's move on to another question. So here's a question from online. Dr. Williams said it's very difficult or impossible to determine why AI models fail in important cases. And yet, on the other hand, there are hundreds of people working on interpretability of neural networks now, claiming they can interpret things about neural network behavior. So which of those two is it? And do the panelists have any recommendations for good ways to identify interpretable functionality or failures in neural models?
I guess since my name was mentioned, I should probably react. I think those are causal things that you're mentioning. More people are working on it because it's a problem. I'm very optimistic that some of this work is going to yield interesting conclusions. I mean, interpretability as a field is not particularly new. A bunch of us were working on it for a while in the context of black box NLP and all of these other things. But there's definitely some interesting new energy around it right now that hopefully will yield some interesting results there. I think one of the things that I was probably meaning when I said that, though I don't remember exactly when I said that, is that particular failures often are tied to the model that you're looking at. So even if you've made some interventions, causal interventions into a particular architecture, those particular interventions may not actually transfer to the next architecture. And if they do, there will be differences that are kind of unpredictable there. So it really is the kind of thing that you have to do local to your particular model. It's not you don't have a general kind of approach to that. I think that would be very cool if that happens eventually. If anyone's working on it, try to find kind of interpretability tools that work for all the models that are quote large language models. It'd be amazing. But you know, lots of things still to come. And I'm sure David and many others have things to say, so.
I'll just briefly say, in cognitive psychology, there are the same question, right? And you know, I think there's a kind of technique which is you ask people why they did stuff, and you you look at what they say. But it's been known for a long time that often people's beliefs about why they said or did something can be proven not to actually be related to the real thing that's causing them to say or do things. And so I actually kind of feel like we're in weirdly similar circumstances studying people in these large language models. So.
The audience have another question? Should I go for Tal?
So I agree with Tom that what we as linguists and cognitive scientists really care about is generalization. But the question is whether we really care about generalization for large language models as they're used in practice, right? So that I think goes to Adina's point about meta evaluation and trying to find if our evaluations actually reflect what we care about. And the question is what we is. I think Adina was a little bit cynical, like maybe what we care about is the ability to create good marketing copy, write a good blog post, or or whatever. But even if we're a little bit less cynical and we say that what we care about is driving customers to a website or providing good customer service as a chatbot or whatever the actual commercial applications of LLMs. It's not that clear that generalization matters so much. Like if there was a way to teach the chatbot to do everything that it needs to do 99.9% of the time, maybe that's fine. Anyway, I just want it's like playing devil's advocate here. So like, yeah, what do you think about that?
If I make an editorial comment, I mean, that might be partly a production comprehension trade-off, because if you're comprehending, you have to understand everything that other people might throw at you. Whereas if you're just producing, providing, you know, one way of communicating idea, you need to communicate, you're done. And so a certain amount of collapse of modes, as they say in the machine learning literature, is okay.
Yeah, I think I agree with that. And I also agree with the thrust of your question, Tal. I just had a small story that you reminded me of when you were saying that, which was, and actually it's related to what you asked as well. Are there any methods for making hard tests if all the tests are beaten? There definitely are. One that I was pretty involved in for a while was the adversarial data set collection, where you collect examples to particularly fool a model that you know about, like let's say, whatever, GPT-4 or something. You collect models or examples for the tasks that the model can't do. And those are still super hard. Models still can't do basically any of the adversarial data sets that I was part of, but these are very strange examples. Humans have no trouble with them, but they're not the sort of thing that are in the distribution for a chat assistant. And so people who are training the models and testing them now have kind of felt like those aren't within the core cases they want to catch for their particular application. And so then that doesn't get tested. So I have had this experience where some things that they don't generalize well to just get kind of dropped off the stack of interesting eval because it's kind of strange, long tail phenomenon kind of stuff. So yeah, just an anecdote.
Yeah, I think that definitely there are cases of generalization which do not matter in practice, but there are plenty that do. As I was trying to make the point with the safety for LLMs, as in we are the engineers and we need to guarantee that the bridge is operational. If you provide a machine translation system, you need to be able, and you sell it to those agencies evaluating asylum claims, then you need to be able to make sure that in that case it generalizes, and that is something doable in practice, because you know presumably who are your customers and what they need, and you need to make sure that to that case that you do generalize.
I'll take another online question, which might have the opportunity to be spicy. Cottrell's talk highlighted the importance of formal language theory, which is often dismissed as an old-style Chomskyan way of thinking. It seems that some of the panelists do view it as old-style Chomskyan, outdated thinking. How big a role do people think formal languages will play in our, LLM-dominated future? Can we respond to that? maybe we should get some opinions from some of the other people at the table, because maybe your opinion is obvious. Anyone else got an opinion on this topic? Tim's going to have a go.
No, I don't think it plays a role.
Tom, no, John, after that.
Yeah, so there was one direction I very briefly alluded to in my talk, which is this approach where you can generate synthetic data that embodies some property that you want a model to have. And in order to be able to do this, you need some model that you can sample this synthetic data from, and formal grammars are perfectly suited for that. So I do think there's a potential role there. And I think there is a lot of increasing interest in synthetic data in training language models, because it's kind of a funny problem that we actually seem to be running out of text. There's just not enough text in the world to continue scaling the training data of language models at the rate it's been going. So people are looking at ways to generate additional synthetic training data. And formal grammars give us the tools to potentially have some fine-grained control over the properties that the synthetic data would have.
So I think like in general, in principle, I think it's good for people to work on diverse things. And also I'm just going to mention like an example with like the entity tracking task that I was talking about in the talk. So I had this kind of a nice conversation with Will Merrill, who was trying to like actually prove kind of what kind of entity tracking tasks can transformers solve in the first place. And then we talked about it and like we saw that different splits or like different kind of tests or versions of the entity tracking task had different implications. So I think like it's good to know that like what the upper bound would be and then what that means for like including some split in the benchmark. So I think there are also ways in which like it can inform like interesting in us and in interesting ways outside of kind of like, okay, like you know, like architectural characterizations.
Okay, Brian, what's your take?
So I think the question sort of missed one of the major points of my talk, which was if you think of a language model as a formal object of study, you have to formally define it. And I don't imagine we take this to any other engineering object. So imagine you want to fly in an airplane. Many of us came in airplanes here, and someone said, I really don't want a mathematical model of this airplane. In fact, I think it's detrimental to the development of new airplanes to have a mathematical understanding of it. And I definitely don't want any theorem that says it's not going to crash, because that's detrimental to progress. I don't think anyone would take that view. All I'm advocating for is you know, you can formally define a language model as a mathematical object. You could propose a different definition than one I had, but as far as I can understand, it is a probabilistic formal language, whether you like it or not. But there are other views of it as well. You know, many mathematical objects have more than one view, and this is just one. But I think it's very hard. So the takeaway is it's very hard to rebut the suggestion that we should formally understand these things that we're going to become an ever increasingly play an ever increasingly large role of our daily lives.
Okay, I'll ask you a question.
Sure. I was curious. I heard a lot of great ideas about how linguistic data and linguistic analyses might be useful for LLM development. What I didn't hear, I think, is whether other kinds of human language data, more like what I might collect. So do we care about M400s and eye movements and self-paced reading times? And is that just performance competence? Is that a different Marian level? Or is there a role for that kind of data in shaping how we develop and evaluate large language models?
I mean, yeah, I think there's definitely a role for that. I think you can run into some of the issues I think that came up in the earlier session where you then get these studies where you look at some correlation between self-paced reading or between eye tracking, and you get some correlation and maybe it's 0.4, and then with some other model it's 0.6, and you're kind of, you sometimes get left with this feeling of, well, what do we do with that? And so I think there's work which kind of has more like work that has more specific clear hypotheses about what the relationship, like what kind of prediction you might get out of a reading time study or an EEG study, and like make some testable prediction with models. That kind of work, yes, it seems interesting and important for this broader goal of understanding similarities and differences between models.
I'm also going to chime in the affirmative this time. I think that, you know, those techniques that we've been developing over many, many years are meant to be giving us some information about, you know, the analogy in the large language model is what the probability distribution is from which the words are getting sampled, right? And there are models in cognitive science that are all about the, you know, choice under conditions of uncertainty, like drift diffusion models and so on, right? Which tightly link the initial probability distribution and other constraints of the task to the speed and error distribution of the responses and so on. And so to the extent that we're trying to find ways of connecting what's going on into the model with things that we can measure in human behavior, you know, those sorts of linking models give us this additional sort of data where we can begin to test those kinds of hypotheses beyond just, was the sentence the thing ultimately sampled out of the probability distribution the right one?
Okay, let me go on with another online question. So there's been some mention of inductive biases in this session's theme. Well, you know, the things linguists discover are putative structural constraints or inductive biases of human language. Whether it's something like, you know, C command and pronouns or Greenbergian word order universals. I mean, to what extent can the things discovered by linguists be successfully used as inductive biases inside large language models? Okay, right.
I would say that if you are a betting person, you would not bet on having a linguistic hypothesis help you build a better model, just given the historical data. Doesn't mean that won't change, but I think a lot of people really want that to be true. And that's why, you know, you get a lot of grad school applicants who tell, you know, they say how they want to include linguistic theory in large language models. They want to do this, like that's a very common theme. People really want it to be true, but things aren't necessarily true just because you want them to be true. And the data over time is pretty clear that the less linguistic inductive bias, the better the models become.
Okay.
Also, some of those things are biases of human cognition and not necessarily biases of corpus data, I guess. So like the Greenberg universals, for example, you don't get those from a single language anyway. You have to look across many languages to understand that there are these sorts of regularities about the order of adjectives or nouns, say. So it's not really clear that you would necessarily need that for a single language model, like an English language model anyway. So some of them, it's sort of the wrong level of abstraction, maybe.
Sort of, but I mean, in the Greenberg, to the extent that you've got correlations between the orders of having verbs and objects and adpositions and their objects, that consistency constraint could conceivably be used within one language to acquire the language more quickly, right?
Yeah, I mean, I would love to see it work. Yeah.
Does anyone want to say there's more hope? Tom does.
Yeah, so I mean, I think it kind of has to be the case that if we could figure out how to get these inductive biases into a model, then it should help them. Just because having inductive biases that get you closer to the true structure of language should enable you to learn language faster and generalize more robustly. I think often the obstacle is just the inductive biases that linguists talk about. It is very unclear how we can translate that into mechanisms inside neural networks. So for example, if it's something like a bias for SOV word order over OVS word order, that's just at a much more abstract level than the way people usually define neural networks. But for the inductive biases that we can translate into neural network architectures, I think there have been a lot of success stories. So I think a clear one is hierarchical tree structure, where, as Saul mentioned, there have been some very nice neural network architectures that build in tree structure, and they generally do learn faster and generalize better. Now, they're not in widespread use just because they also typically have a much higher computational cost. So usually people decide the more effective trade-off is just to throw more data at it. And that's worth having, you know, a model with faster inference. But the inductive biases still are doing what they're supposed to be doing.
Can I add one more thing to that? So I think like I was going to mention some of these. So like I think like from doing the meta-analysis that I mentioned in the talk about like, okay, we proposed this like compositional generalization benchmark. People have proposed kind of tailored solutions that do talk about like inductive biases, some of them inspired by linguistics. I think like one of the papers that I saw like built in kind of this like homomorphism assumption into the model, and that kind of solved the task. But I mentioned like I mentioned, but it's like hard to get those adopted to like mainstream use because of like kind of resource or like kind of scalability concerns. So what I don't really see, where I do think like these kind of stronger inductive biases but more costly models can help, is like actually low resource application to low resource languages. So for those, we don't have data. We are limited by data. So I think like maybe this is just my ignorance, like maybe people have worked on it, but I think if we could show that, okay, like we have these stronger inductive biases, like models with stronger inductive biases, and they actually like give us material benefit for like the acquisition of like lower resource languages, like in terms of like, you know, the cost trade-off, then like I think that would be really convincing evidence and a concrete contribution that I don't see a lot of people exploring, but I just might have missed a lot of stuff.
Sorry, I thought of one more thing when we were talking. There is a strand of research that I've been finding particularly exciting recently, which is called reversal curse. And actually, I think, David, you mentioned it as well, where people are finding issues with models kind of A is to B, B is to A. They are able to do the A is to B direction, not the B is to A direction very well. And this is something that a lot of the ML people I've been talking with in industry are super excited about. It's an issue that they have and might actually try to at least something kind of as abstract as that, try to put that into some architectures going forward, maybe bring back some XLNet ideas or something, we'll see. But yeah, so sometimes there's examples from language that will encourage new architectures to be developed.
Okay, question in the room.
I have a question kind of coming back to a lot of the discourse around LLMs. We often kind of use somewhat deterministic language. We say things like, LLMs produce false statements or incorrect statements. But what we really mean is that, when we generate, some greedy sample from an LLM that doesn't adhere to some scoring function that we have that, dictates whether it's correct in a particular context. And as has kind of been discussed among a bunch of people today, including Ryan, Tom, and others, that LLMs are probability distributions over strings. And surely if you were to, conditional on a prompt, generate a large number of samples, some small subset of those would be correct for whatever that means. And so it seems like we're in this position where LLMs are distributions, but we're sampling from reasonable, but not quite the right distributions that we want to be sampling from. And so the question is, should we be considering, for example, using LLMs as proposal distributions that combined with scoring functions and inference algorithms can help pull those distributions into the type of space that we, want them to be. And then in evaluation, should we be evaluating LLMs only as these isolated siloed systems, or as part of larger scale system designs that place both hard and soft constraints that shape those distributions? How should we be drawing samples for evaluation? And I think this is super under utilized across all eval currently. What are your thoughts?
Okay, Ryan.
Well, I guess the first thing that comes to my mind is I imagine a late night American comedy show where they poll a bunch of Americans. They say, what's the capital of Switzerland? And maybe a third will say Geneva. And maybe that's what the data is trained on. Maybe it should say that the capital of Switzerland is Geneva a third of the time. Maybe that's just what we'd expect. So in that sense, I don't have a problem with it being true or false. It's just a statistical model of the data. But to your point about symbolic sort of constraints, I think if you view a language model as a tool to do a thing, for instance, you might view it as a tool to perform a certain task like a grammatical error correction, and your sole purpose is to produce an engineering object that performs that, then I think you should throw everything you can at it. So if that involves some sort of constraint-based decoding with some proposal distribution and SMC sampler or something, then if that's your engineering task, you should solve it. But so yeah, I mean, that sense, go for it.
Okay, I'll ask another question from online. So there's been discussion for the benchmarks that we have now. Some of them are linguistic benchmarks, something like most NLI problems, and others of them are encoding into human language anything at all, right? Chemistry, math, geography, etc. I think Adina talked about this. And so one person asked, can we work out which parts of our understanding are purely linguistic? And if so, can we and should we be designing tests to evaluate language models on purely linguistic functions? Anna?
Well, there's definitely a sense in which this is necessary again for safety evaluation. Even if you finally want a system that answers questions about chemistry, you first need to make sure that it can parse the questions, right? So, and once you know that it can do that, then you can go on with the chemistry. So I'm not sure if that answers the question.
Yes.
Yes.
Sort of like a precondition before building domain knowledge.
Yes.
Do you think it's vital to separate out those two?
Yeah, so there's a position paper that I did with Anya, who's here, and F. Fedorenko, where we kind of argue for this distinction between evaluating models on their formal competence, which means something kind of like linguistic competence, like linguistic skills as it's being used here, and these other functional skills. And yeah, I think that's valuable to do. I think there's always going to be like some gray areas where it's hard to separate these things. Like even like a natural language inference task, I think gets into a gray area because you're going to have some world knowledge or some semantic component involved. But I think, you know, things that are like strictly trying to focus in on syntactic well-formedness, like, you know, BWIMP or COLA, or you know, morphological well-formedness, or these kinds of things that are really about getting the form of language right, do feel to me like fundamentally different from the kind of gray area things, which are getting into more like meaning and world knowledge, but still kind of mostly language. And then I think there's a whole additional leap to get to, you know, doing chemistry, which again requires some kind of linguistic understanding, but is also tapping into some other very different kind of skill. So it's, for some reason, it's hard to keep straight who said what, but it's one of the talks talked about the was it Najung and unit test, that like it's kind of a precondition for all of this other stuff that you have this linguistic understanding component. But then I think there's still value in pushing the formal linguistic piece itself. Because I think in a lot of cases, the kind of linguistic skill you need to solve like a chemistry problem isn't necessarily actually going to even push on the kinds of, you know, like the linguistic seminar donkey sentences and things and filler gap dependencies. And so having a separate benchmarks for those, I think is valuable.
I just like to offer my hot take. I don't actually believe anything is purely linguistic. I really believe that all of language is connected to many aspects of being a living, thinking being in this universe. I learned a lot from Mary Ellen McDonald at University of Wisconsin, who thinks about speech production, and who pointed out that a lot of the structure in natural language is arguably derived from the fact that it's just really hard to move your tongue very rapidly in certain kinds of patterns, right? And so if I'm planning something complex coming up, I might say or ah, or I might change my syntactic choice about how I'm going to formulate the sentence to give me a little bit more time for the motor planning to do its thing. And if that's really true, then all of the kind of ordering information that LLMs are trained on and that we hear in our language environment are also being shaped by those articulatory constraints. We all were familiar with the McGurk effect, where even the very language sounds that we hear can change depending on what's coming in through our eyes. And so the idea that it's all just present in the acoustic signal can't possibly be right. And I think as you percolate those things from the periphery of articulation and perception all the way down, similar arguments can be made. So I think it's hard to separate linguistics from other.
Let's see, a last question maybe, yeah.
Sure, so this was great, thank you so much. So I heard sort of two sides of things. So one is that linguists and cognitive scientists know how to do a lot of things that would be really helpful for building models, and also that the models are happening at a rapid rate where we're not doing things fast enough, or maybe we don't know the language to be able to communicate our importance to this process of model building. And I just was wondering how do we solve that problem? So if we're convinced that there is a role for linguistics and cognitive science, but it's an underappreciated role right now, what are the steps to take to help that, you know, that gap that people keep on describing as growing and start to shrink?
Yeah, well, I'm not sure about helping with the fast iteration part, but one piece of that I think is, well, the fact that data work has in our field, in natural language processing at least, has been just generally underappreciated. Machine learning is cool, and everything that has to do with data is not. Also because it is slow to do, right? and everything that is cool in machine learning happens fast. So I guess actually this is maybe a part where NSF could help by somehow creating, I don't know, programs, venues, something that would up the prestige of high quality data work, so that there would be incentives to do that, and there would be incentives for the modeling people to engage with it seriously.
Yeah, I think there are multiple issues that lead to the problem that you mentioned. I think one is I think we also need to think about usefulness more in building the benchmarks. Of course, these can be solved as preconditions, but I think it is easier to kind of make the benchmark be adopted or be reflected in the next model development if you can really convince them that it's actually important to get it right. So I think that's one side of thing. The other is I think the communities maybe could use a little more of it. I think Adina mentioned the reversal curse stuff, and then people are really excited about it. I think some of that at least partially is community effect, and then who says what. So I don't think we can solve this issue and I don't know if there is a solution to that, but I think there are multiple issues that coming from different angles here.
A question.
No, it's okay. It's okay. I will have a lot of opportunities later at dinner tomorrow.
Okay, well, we're really counting down the minutes. Has anyone got a final question that they'd like to ask? Carl.
Not a question, just a quick follow-up on what Najing said.
Perfect, since it's gone till 1 minute to go.
Yeah,
Say it.
I'm just reflecting on Hans, the data set that Tom created for it was natural language inference, but really it's very formal. It doesn't require any world knowledge. It's really a formal linguistic data set. And I think it's had quite a bit of impact in the field, which surprised me actually. I thought it was a great data set, but I didn't realize it would be so influential. And I think just reflecting on it, it has this kind of hits a sweet spot between being very simple. It's not, you don't need to be a linguist to understand why it's important to take word order into account when computing language inference. And also the models perform surprisingly poorly on it. But it still has kind of a principled linguistic motivation. So, I don't think that it was successful because any of the authors were famous, because it just wasn't it wasn't a Chris Manning released the data set and everyone starts using it. We were all junior. So I don't know. It's something to think about. Useful, but also something that doesn't require a PhD in linguistics to understand.
Okay. Well, it's officially 5 o'clock.